Welcome to Chapter 4, Section 5. Our objective is to learn to evaluate expressions with exponents. Our essential question, how do I find square roots? We've been working with exponents. Now we're going to work with the inverse of an exponent, a square root. The principal square root and the perfect square are a couple of other vocabulary terms we'll talk about. Think about the relationship between the area of a square and the length of one of its sides. So if the area of the square is 36 square units, the side length would be the square root of 36. So to give you a visual, when you're talking about a square, all the sides are going to be the same. To get the area, we multiply one side by the other side, which would be the same as taking the side squared. The inverse of that is the square root. To get back to where we would have wanted to be to figure out the individual side, we take the square root of s squared. So if we put numbers with that, 6 times 6 is 6 squared, which is 36, and the square root of 36 is 6. So we're really thinking backwards of what number times itself gave us 36 in the first place. A number that when multiplied by itself to form a product is the square root of that product. Taking the square root of a number is the inverse of squaring the number. Every positive number has two square roots, one positive and one negative. The radical symbol, which is the square root sign, that symbol right there, indicates the non-negative or principal square root. So principal square root is the positive version. The symbol with the negative in front is used to indicate the negative square root. The numbers 16, 36, and 49 are examples of perfect squares. A perfect square is a number that has integers as its square roots. Other perfect squares include 1, 4, 9, 25, 64, and 81. Caution: the square root of negative 49 is not the same as the negative square root of 49. A negative number has no real square root. Let's look at some examples. I'm going to put all three up. Find the two square roots of each number. So for the number 49, we're trying to think what number times itself equals 49. Well, that would be 7. 7 times 7 is 49. That's the principal square root. The other square root would be negative 7, because negative 7 times negative 7 also equals 49. Square root of 100 would be 10 and negative 10. Square root of 225 would be 15 and negative 15. A square-shaped kitchen table has an area of 16 square feet. Will it fit through a van door that has a 5-foot wide opening? Write and solve an equation to find the area of the kitchen table. The square root of 16 equals 4. Use the positive square root. A negative length has no meaning. So when you're choosing which of the two roots to use, the positive one is the one to use. So the table is 4 feet wide, which is less than 5 feet, so it will fit through the van door. Simplify. Just like with parentheses, when you see a number in front of a square root sign, it means you're going to multiply those. Think of the square root as an exponent, because really it is the exponent 1/2. So in the order of operations, you would do parentheses first, exponent, which would also include square root, then multiply, divide, add, subtract. So we would start by evaluating the square root of 36, which is 6. Then 3 times 6 is 18, and 18 plus 7 is 25. What if we have a fraction? If you have a square root with a fraction inside of it, the square root is being applied to both parts of the fraction. So we would evaluate them separately. Think about the square root of 25. And then think about the square root of 16. Square root of 25 equals 5. Square root of 16 equals 4. And so we get 5/4, or 1 1/4. 1.25, or 1 1/4, plus 3/4 will give us an answer of 2. Here's another multiplication. 2 times the square root of 25 plus 4. Square root of 25 is 5. 2 times 5 is 10. 10 plus 4 is 14. Another fraction. square root of 18 divided by 2. With this one, because we can divide 18 by 2, we want to do that first. And so we would start by breaking that down to the square root of 9. The other one, we weren't able to get a nice clean number. So we get the square root of 9 plus 1/4. Square root of 9 is 3. 3 plus 1/4 is 3 1/4. So use your previous math skills to determine if you're taking the square root of both numbers, and if they're not perfect squares, if you can divide first. Before we finish our notes, I want to go back for a second, and I want you to make a quick list in your notes of the perfect squares. So I'm going to use this open space to do that. So it's pretty quick. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. And 12 times 12 is 144. They go higher than this, but these are the ones that we most frequently work with. And so when you're looking for perfect squares, you're looking for these numbers that are here on the right-hand side. And within those numbers, you can go backwards from here to figure out what the individual number that was the original square is. So now let's make sure our notes are completed. On the left-hand side, make sure you're writing questions and try to level them. Again, continue to use those keywords that we've discussed. Review your notes and complete the summary before class.